this is a wonderful complex problem. So we have the blue line right here is our function, which is given right down here. And we're supposed to find A, the tangent to the curve at point P, right there. And we're supposed to find the equation of the horizontal tangent to the curve at point Q. Wow. Let's start with A first. So what do we remember? We remember that the derivative is the same thing as the slope of the tangent, which is the same thing as the rate of change. So here is our function. Let's see if we can find the derivative. We want to find y prime. Well, I have three functions that I'm multiplying. The function 1, the function radical 2 cosine x. I'm not multiplying them, I'm adding them. And the function cotangent x. Well, I'm just going to take them each individually. The derivative of 1 is 0. The derivative of 2 cosecant x is radical 2 times, so I just pulled the radical 2 to the front of the derivative, times negative cosecant x cotangent x, that's the derivative of cosecant x, plus, and the derivative of cotangent x would be negative cosecant squared x. So let's kind of just simplify our negatives and get rid of our zeros here. And what I have is I have negative radical 2 cosecant x cotangent x minus cosecant squared x. That is the equation for the slope of my tangent line. Well, I'm trying to find it at this point right here, and at that point right there, my x value is pi over 4. So I have, let's go y prime pi over 4 is equal to negative radical 2 cosecant pi over 4 cotangent pi over 4 minus cosecant square pi over 4. Well, that's equal to negative radical 2 times 2 over radical 2 times 1. So cosecant pi over 4 is 2 over radical 2. Cotangent pi over 4 is 1. Minus 2 over radical 2 squared. Let's work on that a little bit more. That's equal to, well, these radical 2's go away, so I have negative 2 times 1 minus, well, if I square this, I'm going to get 4 over 2. So that's negative 2 minus 2, so negative 4. So the slope of my tangent line at that point, at this point right here, is negative 4. Slope equals negative 4. And in looking at the diagram, that looks like a reasonable assumption. Looks like, and I'm assuming that the diagram is to scale. So this is the slope. I know that the point I'm dealing with is point pi over 4, 4. So I'm just going to write that down here. P pi over 4, comma 4. And going to my trusty point slope form, I'm going to go y minus y1, which is 4, is equal to m, which is negative 4, times x minus pi over 4. Nothing wrong with point-slope form, but if we want to just kind of get it into slope-intercept form, it looks like it might be kind of interesting. I have y minus 4 is equal to negative 4x plus pi. I'm multiplying that right there. And then I'm going to add the 4 to both sides, so I have y is equal to negative 4x plus pi plus 4. So that's a perfect answer in slope-intercept form. This is a perfect answer in point-slope form, no problem. So that is the equation of the tangent line, which was what was asked for in A. Now we have to find the horizontal tangent to the curve at Q. How are we going to do that? Well, let's start out with this really nice equation of the tangent line. So I'm going to copy it right there, and I think I'm going to paste it right there. Okay, so here is the equation of our tangent line. Now, if I go back up to my picture here, I can see that, oh, I don't know what my x value is. I don't know my x value, I don't even know my y value, I don't know anything about Q, except I do know that they're asking for the tangent line that is horizontal. And since the slope of a horizontal line is 0, I can go ahead and I can set, well, the slope of my tangent line, I'm going to set that equal to 0. Now, if I can find out what x is, I'll be in business. Well, when I do these kind of problems, I kind of like to go back to sine and cosine to get rid of these cosecants and cotangents and stuff. So I'm going to have negative radical 2. Well, cosecant is the same thing as 1 over sine x. And cotangent, that's equal to cosine x over sine x. And I'm subtracting 1 over sine squared x. And I'm setting that whole thing equal to 0. So let's kind of multiply this out and see if I can come up with anything helpful. Well, this part here gives me negative 2 cosine x, negative radical 2 cosine x, divided by sine squared x, which is nice because I'm going to now have a common denominator, minus 1 over sine squared x, and that's equal to 0. So that's the same thing as having negative radical 2 cosine x minus 1 over sine squared x, and that's equal to 0. And if I were to multiply both sides by sine squared x, those cancel out. This is still equal to 0. So I have negative radical 2 cosine x minus 1 is equal to 0. Now, I just want to point out that when I multiply by a variable, especially when it's squared on both sides of the equation, I run the danger of introducing a extraneous solution. So I got to keep that in my mind. I just tapped my head. I got to keep that in my mind. So this is telling me I have negative radical 2 cosine x is equal to 1. I just moved the 1 over to that side. So cosine x is equal to 1 divided by negative radical 2. Oh, this is looking pretty good. Let's rationalize that. Multiply by radical 2 over radical 2. And what do you know? I have negative radical 2 over 2. Well, I know where cosine x is equal to negative radical 2 over 2. I go back and I think about my unit circle. Right? And cosine x is equal to negative radical 2 over 2 once right there. Oops, sorry, not that one there. Get rid of that one. Whoops, let's get rid of both of them. Okay. It's equal to negative radical 2 over 2 right there and right there. At 3 pi over 4 and at 5 pi over 4. Well, which one is it? I think it's only one because my diagram here, way back up here, only has one point. I'm looking at the point Q. Well, let's take a look again. So 3 pi over 4, and I have 5 pi over 4. And let's just do some quick estimation. If I say pi is equal to 3, then this gives me 9 over 4, and this gives me 15 over 4. So this one is a little bit bigger than 2, and this one is a little bit less than 4. A little bit less than 4. Let's take a look at my graph. Well, I would say that this point right here is a little bit bigger than 2. 4 is way over here. 5 pi over 4 would be about there. So I think that the x value of this point right here is 3 pi over 4. Important to be able to go back and forth between the graph and your algebra. So if x is equal to 3 pi over 4, I need to know what is the y value here. What is this y value right there? Well, that's on my equation. The equation is that right there. So I'm just going to substitute in 3 pi over 4. So I have 1 of y is equal to 1 plus radical 2 cosecant 3 pi over 4 plus cotangent 3 pi over 4. That's equal to 1 plus radical 2 times 2 over radical 2 minus 1. Cosecant 3 pi over 4 is 2 over radical 2. Cotangent 3 pi over 4, well, that's one of the pi over 4 points, is equal to 1, so it's negative 1. So what I have now is I have is equal to 1 plus, well, they're going to cancel out, 2 minus 1. Well, that's equal to 2. So I know that this point right here is the point 3 pi over 4, comma, 2. So what's the equation of this line? Hey, guess what? It's a horizontal line. So the equation is y is equal to 2. There is no x I need to worry about here. So another really good problem using a lot of different of the skills that you've had.